Alright, in the last video we have seen how to traverse a circular double linked list. Now here we will look at how to reverse traversal. What do we mean by reverse traversal? It means that we start to loop from the last node until we reach the first node. And every time we visit a node and print the value. We know that in circular double linked list there is a backward connection between nodes. So this means that we can traverse backwards through nodes. What we are doing here is we start traverse from the last node until we reach the first node. In each step we print the values of node. And here, in each step, we check if the current node is the first node or not. If it is the first node, we terminate traversal over here. Otherwise, our loop might be infinite, because we know that first node over here points to the last node, so when it reaches the first node, it will go back to the last node. So to prevent this case, in each step, we are checking that if the current node is the first node or not. So if it is first node, we terminate over here. Now in our case, we start looping from the last node, so the last node is node 4. First we visit the last node and print its value. Then we are checking if this node is the first node or not. If it is not, we are continuing to the next node, and here we are printing out its value. In our case, the next node is node 3, and the value of node 3 is 3. And here again we are checking if this is the first node or not. If it is not, we are continuing to the next node. So the next node is node 2 and we are printing the value of node 2 over here. So here again we are checking if this is the first node or not. If it is not, we are continuing to the next node. So the next node is node 1, so we are printing the value of node 1 over here, and we are checking if this is the first node or not. So we see that this is the first node in our circular double linked list, so we terminate our traversal over here. So let's see how does the algorithm of reverse traversal look like. So here again we start checking head value. So if head points to the none, we terminate our algorithm. It means that we don't have any element for reverse traversal. Otherwise we continue to loop from tail to head, and in each step we are printing the value of current node and we are checking if the current node equals to head. If it is equal to head, it means that this is the first node, so we terminate our algorithm over here. Otherwise we are continuing to reverse traversal until we reach the head. So based on this algorithm, let's switch to Visual Studio Code and create reverse traversal over there. So here again, inside Circular Double Linked List class, we will create another method for reverse traversal. So under the Traversal Circular Double Linked List method, we will create another method which is called reverse traversal. So here I will declare a method reverse traversal Circular Double Linked List, and this will take self as a default parameter. Then according to our algorithm, first we will check head value. If self.head is none, then we print saying that there is not any node for reverse traversal. So we are printing out this message. Otherwise, we continue to loop from the tail until we reach the head. So here we will create once again temporary node, but this time it will take the value of tail. So because here in reverse traversal we are starting from the last node. So we know that tail stores the last node's physical location, so we are assigning temp node tail's value. Then inside loop, while temp node, we are printing out the value of temp node. And then we need to write if condition which checks if we reach the first node or not. So if temp node equals self.head, it means that we reach the first node. So we need to terminate our algorithm over here. So I put break over here. Otherwise, in each step, we need to traverse backwards. So that's why I will assign temp node to temp previous. So with this, our method is complete. Now let's see how this is working in practice. So here again we have a code which creates circular double linked list and inserts some elements to it. So here, instead of calling traversal circular double linked list, I will call reverse traversal circular double linked list. Let me save it and let's run our code. You see that this is our circular double linked list. So the last node over here is 1. So we start from 1, then we print out 2, then we print out 5, then we print out 0. So the 0 is first element in our circular double linked list. This means that when we reach 0, we terminate our traversal over here. As you see, our reverse traversal works correctly. Now let's see what is the time and space complexity for reverse traversal. As always, we will start from the first line of code. So here we are checking head value and printing message over here, and we know that this is O1 time complexity. So this part over here takes O1 time complexity. Then we are creating temporary node and assigning tail value to it. So creating a node and assigning value to it is O1 time complexity. Then we start to loop through circular double linked list, and we know that this takes ON time complexity. This if condition and assignment over here inside loop takes O1 time complexity, but whole loop takes ON time complexity. So if we combine all complexities over here, the traversal will take ON time complexity. So the space complexity for this operation over here is O1, because here we are just creating one temporary node. So it does not require an extra space in the memories. That's why it takes O1 space complexity. So this is all for this lecture. So in this lecture we have learned how can we reverse traversal circular double linked list, and we learned what is the time and space complexity for this operation over here. Now in the next lecture, let's see how can we find a node in circular double linked list. So see you in the next lecture.